We are going to be working on S.6, which is called the addition method. And what I want to really emphasize is that the addition method doesn't give you a different answer than the substitution method or the graphing method or just making a table. You are still finding the point where two lines intersect. This is just a nice shortcut. Many people think that this is the easiest way. Before we start the addition method, I want to really emphasize that I can take an equation and I can do whatever I want to it as long as I do the same thing to every term. So if I take this top equation and I multiply every term by 3, if I get 6x plus 9y is equal to 30, my x and my y are still the same thing. This is still the same equation as the equation above. And if I took the top equation and I multiplied everything times -2, and I got -4x minus 6y is equal to -20, this is still the same equation. These two, the purple and the red, are the same. They're not any different. And finally, if I made it look really strange, say I divided everything by a fourth, I would get 2/4 x minus or plus 3/4 y is equal to 10/4. Now, the green one is ugly, and we probably don't want to use that. In fact, there are very few times when mathematically we would want to use that. But I want you to emphasize that these three equations are all equal to each other. That's what I want to emphasize here. So, when we move on to the actual addition method, our goal is going to be to try to eliminate one of the variables. Right now, if I would add these two equations together, I would get 6x plus 8y is equal to 14. My goal is to have one of these two numbers be 0, because then I can solve for the other number. So the problem that I have, though, is if I currently add them together, I'm not getting 0. So I need to change one of the equations to make that addition be 0. What I'm going to do is I'm going to take this top equation, and I want this to become -4x, because I know that 4x plus a -4x is 0. In order to do that, I'm going to multiply the top equation by -2. But like we showed in the last slide, if I do that, I have to multiply every term by -2. 3y times -2 is -6y. 5 times -2 is -10. And now something I like to do is I like to cross out the equation that I've already changed. And now I'm working with these two. Now I want to add them together. And so I get 4x plus a -4x, that's 0x. 5y plus a -6y, that's -1y. And 9 plus a -10, that's -1. So if I simplify this, I get -1y is equal to -1. So I divide every term by -1. And I get y is equal to +1. Now, just like the substitution method, I have to plug this back into one of the two equations, either this one, or even the original, to try to find what my x is. So I'm going to pick this equation right here, but I'm also going to do this equation here to show you that they both work. So I'm going to get 4x plus 5 times 1 is equal to 9. So I get 4x plus 5 is equal to 9. And now I can solve. So I get 4x is equal to 4. And so I get x is equal to 1. And let's say I decided to plug it into this equation as well. I would get -4x minus 6 times 1 is equal to -10. So I get -4x minus 6 is equal to 10. And if I solve this out, I would get x is equal to 1 as well. So my answer is the ordered pair 1, 1. And that's where these two lines intersect. we are going to be solving this third problem, and I'm hoping that you notice right away that our variables do not match up. Our x and our y are lining up, and our y and our x line up, so we need to rewrite the top equation so that it works a little bit easier for us. So I'm going to rewrite this equation as 3y minus 3x is equal to 27. It's the same equation, just rewriting it, making it a little bit easier to read. And what I want to do is I need to make it so that when we add the equations together, one of the variables is 0y or 0x to make that variable go away. So what I'm going to do is I'm going to make the top equation into 12y, and I'm going to make the bottom equation into negative 12y. So that means this one, I have to multiply the entire equation by negative 4, and the top equation, I have to multiply everything times a positive 3. So this becomes 12y plus 6x is equal to, that's going to be 20 times 3 plus 4 times 3, which is 72. The bottom equation, now I have to do the same process except times negative 4. So that's going to be a positive 12x. And that's going to be 27 times 4. That's going to be 20 times 4, which is 80, plus 7 times 4, which is 28. So this is going to be a positive 108, negative 108, sorry about that. So then I add the two equations together, and I end up getting 0y plus 18x is equal to negative 36. So then I have to divide by 18, and I get x is equal to negative 2. Now, I can plug that x back into any equation that I've been working with. I actually have 5 options. I'm going to plug that x back into this equation right there, but you could have picked any other. So I'm going to go negative 3 times negative 2 plus 3y is equal to 27. So I get 6 plus 3y is equal to 27. I'm going to subtract 6 from both sides. So I get 3y is equal to 21. I'm going to divide both sides by 3. So get x or y is equal to 7. Now I'm going to say that these two lines will intersect at the point negative 2, comma 7. And that should be my answer. If you have any questions, please let me know. The addition method most of the time is easier than the substitution method, but it's not necessarily easy at the beginning. So ask questions when you need them. And as always, if you find a mistake, make sure you let me know.